This lesson covers the subject of the removal and prevention of contaminants, such as ice, snow, slush and frost, from aeroplane surfaces prior to flight, in associated weather conditions. Any accumulation of ice, frost or snow on an aircraft, and particularly on the flying surfaces, that is, the wings and tail unit, can have a severely detrimental effect on an aeroplane's ability to fly as expected, or indeed at all. The Potomac River crash of January 1982, in which 4 people on the ground and 74 people in the aircraft died, and only 5 on board survived, is a sobering reminder of what can go wrong if proper procedures and techniques are not used in such situations. The Air Florida Boeing 737, delayed by a snowstorm over Washington, was inadequately de-iced, and attempted to take off with snow still falling and not fully cleared from the wings, and without the engine ice protection on. It took almost the full length of the runway to take off, but never got properly airborne, reaching only 350 feet. 30 seconds after liftoff, it stalled and hit a bridge over the Potomac River, killing 4 people stuck in traffic, broke up, and crashed into the ice-covered river less than a mile from Washington National Airport. As with most accidents, the crash was the result of several factors. In this case, the weather was the initial cause, but exacerbated by delays and failures by both ground staff and flight crew. The ground de-icing crew used incorrectly maintained and modified equipment and non-standard procedures, and the captain made a series of errors of procedure and ill-judged handling decisions. The captain also ignored warnings from his co-pilot, which, had he heeded them, would have avoided the crash, as would any break in the chain of events. Remember that any surface contamination must be removed before flight, and the correct procedures followed according to the conditions. Ice, snow or frost on an aircraft will have several effects. All deposits, of course, require temperatures at or below 0 degrees Celsius to persist, and the nature of the effect will cause a serious reduction of aeroplane performance. The aerodynamic effects of airframe contamination are to change both the shape and surface texture of the wings and tail unit. Lift can be reduced by 30% or more, and drag increased by as much as 40%. Such changes will increase stalling speeds, reduce controllability, and alter handling characteristics. You will be flying an aircraft with a wing of unknown and variable aerofoil section and untested behavior. Any deposit of snow, ice or frost will increase the aircraft's mass, and can also affect the center of gravity. A mass increase will increase stalling speeds. A change in center of gravity will affect stability, and may also increase stalling speeds. Do not be deceived by such misconceptions as the snow will blow off the wings during the takeoff run. It doesn't, as pilots who have tried this dubious method of snow clearance have found to their cost. Ice build-up on windscreens can obscure vision, and on radio aerials can disrupt communications. Operation of undercarriage and flaps can be affected by water freezing in landing gear and doors and in flap tracks. Functional and indication faults can be caused by frozen microswitches, as illustrated on the screen. Ice forming on or in pitot tubes, static vents, and angle of attack vanes can cause erroneous readings or indications of speed, altitude, rate of climb or descent, or angle of attack. Affected air data systems giving engine power information would also give incorrect readings, as was the case in the Air Florida accident. Engines themselves, and not only their indications, can also be affected by icing. Ice formed on and in intakes can break off and be ingested, causing damage to fan and compressor blades, and ice accretion on the blades would reduce engine efficiency, and may even cause compressor stall. Piston engines can be affected by carburetor icing, which can occur at temperatures well above 0. As we have mentioned before, any deposits of ice, snow or frost must be removed before flight. The International Civil Aviation Organization, ICAO, have defined in their document 9640 what is known as the clean aircraft concept, which states that during conditions that are conducive to the formation of aircraft ice during ground operations, a commander shall not attempt to take off unless the external surfaces are clear of any deposits of ice which may adversely affect the performance of the aircraft. The commander shall not fly the aircraft if icing is expected, and the aircraft is not certificated for flight where icing is expected. Guidance on procedures can be found in the ICAO Operations Manual. Part A includes ground procedures, and Part B contains procedures for flight in known icing conditions. It is worth defining at this stage the two categories of ice protection: de-icing and anti-icing. De-icing involves the removal of deposits of ice, snow or frost which have already formed on the aircraft, and anti-icing involves processes which prevent the formation of such deposits. There are several approved methods of clearing ice or snow contamination. The most widely used and the most dependable is the application of de-icing fluid, either from special vehicles or, more rarely, from taxi-through spray bays. The airframe can be warmed with hot air blowers. Or, more suitable for smaller aircraft, surfaces can be manually swept of light accumulations of frost, snow or ice. Additionally, there are in service a small number of a taxi-through system, which uses infrared heat to disperse ice and snow. Next, you will learn in more detail about the de-icing procedures. Ground de-icing and anti-icing can be either a one-stage or two-stage procedure. The single step consists of the application of a combined de-icing and anti-icing fluid, which removes frozen deposits and protects the cleared surfaces from further accumulations for a limited time. There are three types of combined fluid, all of which are normally applied heated, either neat or diluted with hot water. The thickened fluids are designed to stick to the airframe long enough to prevent deposits forming, but to have been dispersed by the airflow on reaching around 100 knots on the takeoff roll. The two-stage procedure involves first the removal of ice, frost or snow, and then an anti-icing process. The fluids for both processes have what is known as a holdover time, which is the length of time an aircraft can wait until takeoff before needing retreatment. It is dependent on mixture strength, airframe temperature and weather conditions, particularly the ambient temperature and type and severity of expected contaminant, for example, frost, heavy snow and freezing rain. The holdover time for a one-step procedure will start from the very beginning, and for a two-step procedure it will start from the commencement of the anti-icing procedure. The de-icing operators should inform the flight crew of the type of fluid, the dilution proportions, and the time at which application started, to enable the crew to check the holdover time. These three pieces of information form what is known as the anti-icing code. The aircraft should be ready for departure before expiry of the holdover time. If it is not, then the de-icing and anti-icing procedure should be repeated if conditions dictate and a contamination hazard still exists. It is important to note that the holdover time and protection will be shortened and may go below the lowest range in cases of heavy precipitation rates, high moisture content, high wind velocity, and jet or prop blast from preceding aeroplanes whilst taxiing. In this lesson, we have covered the types of contamination that can build up on aeroplane surfaces on the ground, and how they can seriously reduce performance if they are not removed prior to takeoff. In addition, we have looked at the various treatments used for removal and prevention of contamination, and why the flight crew must be aware of the treatment and holdover times. In extreme weather conditions, it is important for all concerned when preparing aeroplanes for departure that the clean aeroplane concept is adopted.